Okay, here we have a train travelling between two stations, P and Q. So here's where it starts at P, and here's where it finishes at Q. And we're given the times and the velocity. We're asked to find the acceleration during the first minute. Now that means we want to find the gradient of this part of the graph. The gradient then, the vertical is 30, the horizontal is 60. The gradient is just going to be 30 over 60, in other words, a half a meter per second. Okay, next bit says find the distance from P to Q. In other words, we want to find the area of all of this trapezium. Well, if you look at the area there, it's going to be the sum of the parallel sides of from 60 to 240. That's 180. So it's 180 from up here, plus the 300 at the bottom, divided by 2, multiplied by the perpendicular distance between those parallel lines, which is 30. In other words, 480 divided by 2, well, that's 240. 240 multiplied by 30 then is 7,200 meters. We're told now that something changes in that there's a part of the track which is being repaired, and the train for that part of the track is restricted to a maximum speed of 10 meters per second. Now that's for the 2,000 meter length of track lying halfway between P and Q. Basically what that means is that somewhere here in the middle of the journey there is a section of 2,000 meters where the speed is restricted to just 10 meters per second. So that's just 10 meters per second. And we know that that area is going to be just, where are we? We know that that area is going to be 2,000 meters. If I put this in here, it means that this area here in the middle is 2,000 meters. And I can do something else there. Because I know that the height here is 10, I know that the length of this rectangle must be 200. So it must be 200 seconds for that central stage of the journey. The question then says that for the parts of the journey where it's accelerating or decelerating, that it's going to have the same acceleration and deceleration as it did in the first place. Now, if we look at the deceleration, we already know that the acceleration is a half meter per second. For the deceleration, that's this bit here, we can see that the deceleration is going to be 30 over 60 again. In other words, the deceleration is also going to be a half a meter per second, same as the acceleration. So let's look at what that actually means here. Okay, what it means is that it also says that the train is accelerating or decelerating at this same rate for the other parts of the journey. What must happen is that first of all, it's going to have to accelerate. So it's going to have to accelerate, and the question says that it accelerates to a maximum speed, and it can't go any faster than this speed, to a maximum speed of 30 meters per second. So that up there is 30. And it then stays at that same speed until it has to decelerate. So it stays at 30, sees the 2,000 meter repaired section coming up, and it then has to decelerate. And it will decelerate so that the gradient of this part here and the gradient of this part here, gradient here is a half, the gradient here is going to be minus a half, and that's crucial later. And for the later part of the journey, the same thing is going to be happening. It's going to have to, after it's done its short section, the slower section, it's going to have to accelerate back to 30. It's going to have to carry on at 30 for a while, and then it's going to have to decelerate again so that it completes the whole journey in the same overall journey. Actually, the last bit I just said there was rubbish. It's not going to be the same journey time at all. What we do know, though, is that the whole thing must be symmetrical, because there's no difference between what's happening in the first part here and in the second part here. The two are symmetrical, and we do know that the total journey time is 7,200 meters. We also know that this section in the middle here is 2,000 meters, which means that the other two sections must take up 5,200 meters. In other words, the area of all of this bit must be half of 5,200 meters, which is 2,600 meters, and that's the same as the area of this bit. Let's just rub out the wiggles there, so that'll help. Okay, so what we've got to do is work out the area basically of this section. Okay, first of all, if we look at this first triangle here, we know that the area of that triangle is just going to be the half the base times the height. But we know if the acceleration is a half and the height is 30, then this is going to have to be 60 across the bottom here for the gradient to be a half, which means that the area of this bit, this triangle, is going to be 60 multiplied by 30 divided by 2. In other words, 900 meters. So the area of this first triangle is 900 meters. Now that leaves us this section here, and I'm going to just redraw that section here. So I've got a shape. Let's do that again. Okay, so the area that I want to find is this sort of non-trapezium. What I can see that it actually is it's a sort of rectangle with a triangle chopped out of it. Let's just draw it like that. Okay, so what I know about this section, so I'm basically talking about this section here. I don't know the distance across the bottom. I'm going to call that distance x. I do know that the height of it is 30, and I know a little bit more. I know that this length here is 10, which means that this length here is 20. And because the gradient of this bit must be minus a half, I know that this little piece here must be 40 seconds, because 20 divided by 40 is going to give me my half. Okay, if I look at the area of that rectangle, the area of the rectangle, if I call it x across the bottom, the area of the rectangle, what I'm going to actually do here is take the rectangle and then subtract this triangle here, and the area of this triangle must be the same as this little one here. So the area of the whole shape there, the black shape is what I'm actually trying to find, is going to be x across the bottom, and it's also going to be 30 high, so in other words, x multiplied by 30. Take away this little triangle in the corner, and the area of this triangle is going to be 20 times 40 divided by 2. And I know that I can work out the area of that shape. Okay, we figured out before that the area of all of this, let's just highlight it in red, the area of all of this, as we worked out before, is going to have to be this 2,600 meters. And we worked out earlier that this part here, this triangle here, has an area of 900 meters, which means that this shape here must have an area of 2,600, take away the 900 meters, which is that triangle on the left. In other words, 1,700. So if we calculate all of this, then the area, so we basically, what we've got there is we've got 30x minus, so 20 times 40 divided by 2, well, that's 800 divided by 2, well, that's 400. That must equal 1,700. So 30x is going to equal 2,100, which gives us x equaling 70 seconds. There we go. So there's my x, which is 70 seconds. And I can see that this part, remember, because the whole thing is symmetrical, if this is 130 seconds from here to here, this must also be 130 seconds from here to here. And if you want to work out then the total journey time, we need to add the 130 and the 200 and the 130. Well, that's 460, 560. That comes out as 460 seconds. So we've got the 200 plus 130 plus the other 130 is 460 seconds.